Okay, welcome back again to Triple M Online Academy. And this is the second lecture for ES1, online lecture for ES1. So I hope you had a refreshing break last time because the first lecture we had was kind of mentally draining. So I hope you come back refreshed, and I'll introduce to you two new concepts now. So we have what we call as your true length. And by the way, I've made a few adjustments. So I've inverted the colors. I'm just testing out if this works better as compared to the white background. So let me know in the comments down below. Sure. I'm kidding, of course. Okay. So we have what we call as your true length, or you abbreviate it as TL, and we have your point view or PV. Okay, so let's first deal with this true length right here now. So what is true length? Okay, earlier when we discussed about the different types of projection, we mentioned the term foreshortening. No, foreshortening. And I think I'm spelling it right. Foreshortening. So foreshortening is when we project a certain line or object and it does not show it in its true size or its maximum length. Okay, because for any line, and just to simplify now, for any line or any object, there will always be a maximum length for that object, which is its true length now. So uh, uh, to give you an imagination of this, and I'll make this an exaggerated version. So try to imagine a tube, and we'll say that um, this tube is a line. No? So if we have a tube, for example, this is a tube. If we view it this way, if this is the true length of the true length, then we should view it in its true length, something like that. But try to imagine that we rotate this tube in this direction, and this time I'll exaggerate the foreshortening effect now. So if we rotate it, the tube will look something like this. See? So its length now will be shorter. This length here is shorter than this true length, and this is what we call as a foreshortened length and length. Okay, and since I've drawn this in a exaggerated fashion, wherein I made it seem like it's a 3D object, you can clearly see that it's not the true length. No, but when we are talking about lines, for example, if I convert this into a line, and this is its true length, if I rotated it and draw the foreshortened view, it's difficult to tell if it's rotated or not. So there is no way for me to know if this is a foreshortened length or if it's a true length. Okay. Another visual exercise you can do to imagine this true length is just hold up your pen and hold it such that it is parallel to the plane facing you, to your viewing plane, and you can see that the your pen will look in its maximum length. Correct. Now try rotating your pen and to really simulate a two-dimensional projection. Close one of your eyes, just look at the pen. You will see that the pen seems to be shortening, no, when you rotate it, and that is a visual representation or visual exercise on how foreshortening occurs. Okay, so um, if we again if we rotated this tube right here or pen in our exercise, and then we will see that there are different angles which show foreshortened length, but there will always be that one view that will show it in its true length, and that view is when, and I'll try to draw it in space again now. So if this is your pen in space, pen or tube in space, the only view that will give me the true length is when I am viewing it in a reference plane where this tube or plane is parallel to this. This tube or this pen is parallel to this plane. Okay, so if I projected it as such, then I should see the true length. Uh, Something like this. Okay. Similarly, if I took something like this, there are infinite number of planes that are parallel to this pen. No? So if I take a plane such as this one and try to project it there, then I will also similarly see the true length of this pen. Okay, so our goal here is to find this parallel plane, this viewing plane that will give me the true length of my line, and in this case a tube or a pen. So how do we find this plane, this parallel reference plane? Okay, so what we need to do is, if we are coming from a particular foreshortened view, what we actually just need to do is just, if this is your foreshortened, for example, and I'll just copy this now. If I take this is the foreshortened length. If I put a reference plane here that is parallel to the foreshortened view, then when I view it here, I should be able to look at this uh, pen right here or tube in something like this. Okay, something like that. So by viewing it in a plane, in a folding line, so as to speak now, this is a folding line for this reference plane right here that is parallel to this original pen or tube or line, whatever you want to call it, then I should get a view wherein the tube or the pen is in its true length. Okay, so let's try to do this, no? This conceptual understanding of how true lengths um, are generated, and let's do it in our module now. Okay, so we have this line right here. So we have line AB that is shown in its HRP and FRP. Okay, so if we want to get the true length, all we need to do is either draw a parallel line here, and this will be our folding line for ARP or HRP, or we can also do a parallel line here. Again, the reference line or the reference plane should be parallel to this line we are trying to expose the true length of. Okay, so obviously if you do it above, you won't have enough space, so we'll just try to do it below now. Okay, so again, you can use your ruler and triangle to generate the parallel lines. Here in Photoshop, I'll just use my shift key now. So I'll generate a reference plane. Okay, Now this is my folding line separating my, this is FRP. This is the view above, then the view below should be my auxiliary reference plane. Okay. Now that I have my auxiliary reference plane, I can now create projection lines. Project it downwards, project this downwards, and using my compass, I'll now let me just connect these two now so I can measure the distance. So again, from the lesson we learned from the last video, to get the distances, or first to get the projection lines, we just need the view before it. So if this is ARP1, this is ARP, then one view before it is the FRP, and this is the basis for our projection lines. If we want to get the measurements, then our basis should be the two views before it. So this is our view. So 1, 2, this is the view we are looking at. And again, we use two folding lines. Okay, so this is the first one, then this one. Okay, so I'll use again my pseudo compass for this now. So if I measure the distance from the folding line separating HRP and FRP to A, and copy that distance here. Oop. Then again, I'll copy the distance of B like so, and then copy it into ARP. I'll hide my compass. This will now be the location of my A, and this is B. And if I connect it, this is now my final answer. This is the true length, and when we have a true length, we usually write TL above the line, above or below the line, to signify that it is in its true length. Okay. Okay. Now let's do an experiment now. So from the TL view, let's try to draw any adjacent reference plane and try to look at what we can observe. So if you draw a random reference plane, say for example this reference plane right here. Okay. Now let's try to project like so. Then open up my pseudo compass again. And this is the view we are manipulating. And let me label my reference planes first now. So we have, this is now, I'll now call this as ARP1, and therefore this is ARP1, and this is ARP2. Okay, so again we are measuring from we are manipulating ARP2 or completing ARP2, therefore we should be looking at two views away for the measurement. So this is ARP2, 1, 2. So we measure from this one, and again we'll measure from two folding lines away. So this is 1, 2. So we'll measure from here to here, and not from here to here. Okay. So let's take my compass again. Place it A. Copy distance A. Okay. And let's copy distance B, and you'll see that it's actually the same distance now, because when we generated the true length, we did a parallel line. So the observation here is that if we did a true length, if we have a true length, let's hide the compass. If we have a true length like so, this is A. Any view before and after it, and I'm saying any view adjacent to it, that's either before it or after it, will always be parallel to the folding line. Okay, so that is the key observation when you do true lengths. Okay, so that's for true lengths. Now let's proceed with point view. So let's go with point view, and let me just extend my working space here now. And let me paint this black. Okay, so let's go with point view. Okay, so point view is when we have a line and we view it as though it were a point. So the only view we can do that is, let's try the pen example again, the pen or the tube. So we have, and I'll copy this again now. Okay, oh sorry, copy it again. Okay, now let's try rotating this again. This pen, we rotate it again in a manner where we now only see the radius or the circumference of the tube or the pen, whatever we are looking at now. Okay, so when this occurs as a, and this is an exaggerated version again now, if this occurs in the as a line, then this will actually make it appear as though it were a point, and this is what we call as the point view of a line. Okay, so how can we see the point view of a line? So it's easier to imagine if we use the pen analogy again. So try holding up your pen and try rotating your pen, and you'll figure out that the only view where you can see the pen as though it were a point is if you're looking at the pen where the pen is directly perpendicular to your viewing plane, correct? So if we have for example this same pen right here, pen or tube, the only view where we can see this as a point view is when we have a plane that is perpendicular to this one, or we can also have the plane right here, correct? If you're viewing it from this or from at the back moving there. Okay, so if you view it this way, if we project it, we can see it as though it were a point. Similarly, if we project it, we can view it as though it were a point. Okay, so to get this point view, what we need to do is find the true length first. If we find the true length, then we can find the point view. Okay, because what we are doing is we are sort of let's use this example now. So if we find this true length right here, if we view it this way, then we should get the point view. It makes sense that we should get the point view right here, and it should look something like this. Okay, and for point view, we usually label it with PV, like so. Okay, so let's try it in our module now. So we have this one. We need to draw the point view of this given plane. Okay, so first let's do the auxiliary reference plane. So again, the first reference plane we create is to expose this line in its true length, and again what we need to do is we need to create a parallel reference plane. So again, using your triangle sliding triangle technique, just draw a parallel reference plane, and this now is my FRP, this is my ARP1. Again, you can also opt to do a parallel reference plane on the upper side, but again, the issue is for this example, wala tayong space sa taas, no? So we do it at the bottom side. Okay, Okay, so now that we have our parallel reference plane, let me just adjust it a little bit. Okay, now we have a parallel reference plane. Let's now do our projections. So again, first step to finding any point or line in a given view is to do the projections. So again, this projection is perpendicular to the folding line. Okay, so after getting the projection line, we get the distances, and distances, as I've mentioned earlier in module 1, is always two views away from the view we are manipulating. Okay, so if this is the view we are manipulating, ARP1, then two views is 1, 2. Okay, so this is the basis for our distance. Now let's again bring our compass back. Compass, and we measure distances. So just it. Measure point C from the second view, measured from the second reference line. So this is folding line 1, folding line 2, therefore we should measure it from there. Okay, so we have, and then class, to give yourself some time to practice, please, you can do this you can follow along this video and do the modules yourself now. You can pause it if you need to time to catch up, and you can replay the video so that you can follow along. Okay, so again, see point D, we'll get the distance of point D. Okay, measure that one, have it down, and we have point D right here. And let me just check, class, if I'm actually recording. Yes, I am recording. Okay, so this is now my line CD in its true length. Okay, this is line CD in its true length. And what we'll do is we'll create a perpendicular line from this true length. So again, use your sliding triangle technique. I'll just align it with one edge and draw a perpendicular reference plane. This is now my ARP1, and this new reference plane here is now ARP2. Okay, then I project, and since notice here, class, now since it is let me color this a different line. Okay, since this line CD here is perpendicular to ARP1, then you actually just get a single projection line for both points C and point D. Correct? Okay, so both points C and D will lie within this projection line. And since we came from a true length, and again, the observation we made earlier is that all views before and after true length should produce a line that is parallel to the folding line or the reference plane. Correct? So therefore, if you look at it, this is the view we're manipulating on. So two views away is one view, two view here in FRP, and if we measure, we actually get a parallel line again. Okay, so since it's parallel, then this distance should be equal to this distance. Therefore, both C and D should be located at the same exact point. Let me pause the video first. Okay, I'm back, class. So, matok lang roommate ko kasi kain daw kami. Okay, so hopefully you've eaten your dinner as well. Para refresh ka, no? So where did we leave off? Okay, we noted that we have only one projection line for points C and D, and that because the reference for the distances is a parallel line, therefore the distance here and distance here will be equal, giving us a singular point for the points D and point C. Okay, so we label this as point DC, and notice I used DC instead of CD because usually the convention is whatever point is closer will be stated first. So for example, this one, from this folding line here, D is the closest one, so we label this as point DC, and can to indicate that it is in its point view, um, we write the symbol PB. Okay, so if we remove the compass, we'll see that this is now the line CD as shown in its point view. Okay, and to complete this, I'll just draw a crosshair now. So usually class, if we are drawing points, we label them as, or we indicate them as crosshairs now. Okay, so let's do this one. So from the PV plane, or from the plane showing the line in its point view, let's draw any adjacent reference plane and see what we can observe. So I'll just draw a random reference plane. So I'll just say, for example, this reference plane right here, and this is ARP2 and this is ARP3. Okay, so let's project it like so, and we take our pseudo compass and we measure 2 views away. So this is the view ARP3, 2 views, 1, 2. We measure from ARP1. So from ARP1, measure, this is point D. Okay, point D. Let's mark off point D. That's here. Tapos let's take our compass again, and let's mark off our point C. It's a huge distance. Point C is there. Transfer point C should be sakto at the edge. It's at the edge, so let me just extend this now. Okay, so hide our compass. This is now point C. No, sorry, point D. This is point C, and let me use a white pen signifying this is a final answer, and therefore this is my final answer. See, and notice that coming from a point view, we will always get a true length. Okay, so it makes sense, no? Because if we look at this example, for example, if you're looking at your pen, if you take an adjacent view, and take note, adjacent views are always perpendicular to each other. So if I take a perpendicular view here, then I will always be viewing this pen here or tube again in its true length. And bukod sa true length siya, it is also perpendicular to the folding line. Okay, and that is true for any adjacent view. Okay, so I think that's all for the true length and point views. So hopefully you've learned something from these 2 videos, and Let me just look. Meron pa bang kailangan discuss? I think that's all for this video. So, I'll see you guys on Tuesday. Oh no, I'm sorry. Yes, yes. On Tuesday, and we'll be discussing edge view and true size. Okay? So, since another important note in class now, since we are actually one lecture behind the WF classes, I may have to upload another lecture so that we can catch up now. Okay, so that's for another time. So I'll see you on Tuesday, and hopefully you have finished plate number. Which plate is this? Basta yung plate that is for the true length and the point view. No? So see you in the next one. Peace.